roll 2 coins, flip 2 coins, probability of getting 2 heads. Well, that's this event happening. I'm going to take my probabilities and multiply them. So probability of heads is 1/2 times 1/2, which is 1/4. Notice we said earlier that these all have equal chance of happening. Well, one of these things is going to happen, so the sum of all these probabilities would be 1. Since they're equal, they're all going to have 1/4 of the chance of happening. So in that way, my sample space can help me think of this, but here only because they're equal. All right, if I roll 3 dice, a sample space of getting exactly 2 6s. Well, with 3 dice, I could make a list, but that's going to be a pretty big list. I can't make a 2D grid because I have 3 things happening, so I could use a tree diagram. So my first die, right now what I care about is getting a 6 or not getting a 6. So I could get a 6 or not a 6. I'm going to use my apostrophe to indicate not. And then with my second die, I could get, again, a 6 or not a 6, a 6 or not a 6. And then the same thing with the third die. I'm going to get 6 or not 6, 6 or not 6. Same thing, 6 or not 6. Should have written those a bit smaller. 6 or not 6. So I want exactly 2 6s. So following this set of branches, this is the outcome where I would get 3 6s. So that one is not one I want. But I could follow this branch, and then this branch. That would indicate that I would get 6, 6, and not 6. So this does have exactly 2 6s. The probability of that happening, so the probability of this, well, the probability of getting a 6 is 1 out of 6, 1 out of 6, 5 out of 6. So I'm going to end up with 5 out of 6 cubed. I could have this happen again, 6, not 6, 6. That's going to give me exactly 2 6s. I can't follow this track because I would have only 1 6. Following this way, I can only take this track to give me not 6, 6, 6. So I have 3 different ways that I could end up with getting exactly 2 6s. So in the end, the probability of exactly 2 6s is going to be 3 times 5 out of 6 cubed. So I looked for scenarios and arrangements that give me exactly 2 6s, and in the end, sum the probabilities. Since they were all the same, I could instead multiply by 3.